You buy a metal detector to find a few lost coins in your backyard. Instead, you dig up a dinosaur bone. That's basically what just happened to NASA. TESS, one of NASA's most successful planet-hunting telescopes, was built to do exactly one job: catch planets crossing in front of nearby stars. Instead, buried in its own archive, it had quietly recorded a giant planet nearly 40,000 light-years away, one of the most distant worlds ever found this way. The light you're about to see left its star 40,000 years ago, back when Neanderthals still walked the Earth. TESS wasn't built for this. It wasn't looking for this. Scientists didn't think it could find this. This discovery was only confirmed a couple of days ago. It just quietly rewrote what one of NASA's telescopes can do. Finding a planet outside our solar system should be impossible. Planets don't shine. Stars do. Trying to spot an exoplanet directly is like trying to catch a firefly's glow standing right next to a lighthouse, from 100 miles away. So astronomers stopped looking for the planet and started looking for its shadow. This is the transit method. If a planet crosses directly between its star and Earth, it blocks a sliver of that star's light. The star dims, just slightly, then brightens again. If that dip repeats on a steady rhythm, there's a planet down there. That's the job TESS was built for. Launched in 2018, TESS watches enormous patches of sky, tracking the brightness of hundreds of thousands of stars with extraordinary precision. It's helped confirm thousands of new worlds and reshaped how we understand planetary systems. But there's a catch. The transit method only works well on planets orbiting close to their star. And that star usually has to be relatively close to Earth, too. TESS's usual hunting ground? A few hundred light-years, not tens of thousands. So how did it find something almost halfway across our galaxy? According to Einstein's general theory of relativity, gravity isn't just a pull, it's a warp. Mass bends space and time itself. And when light travels through that bent space, its path bends with it. When a massive star drifts directly in front of another star far behind it, its gravity bends that background star's light toward us. From Earth, that background star suddenly looks brighter. Not because it's producing more light, but because gravity is acting like a lens, focusing that light straight at us. Astronomers call this gravitational microlensing. Unlike the transit method, this doesn't need us to catch a planet crossing its star. It needs something rarer. Two completely unrelated stars, sometimes tens of thousands of light-years apart, lining up almost perfectly as seen from Earth. When that happens, the near star brightens the far one, and if that near star has a planet orbiting it, the planet leaves behind a tiny ripple in the brightness, a brief flicker, a fingerprint hidden inside the light. These events are extraordinarily rare. They can't be predicted years in advance. They don't repeat. Miss it, and it's gone. Forever. Which makes what happened next even stranger. In April 2023, the European Space Agency's Gaia spacecraft noticed something odd. One faint, distant star was rapidly getting brighter. To astronomers, this had the signature of a microlensing event. An alert went out to observatories across the planet. Everyone knew. There's only one chance to study this. Then someone asked a simple question. What if TESS happened to be pointed at the same patch of sky? At first, that seemed unlikely. TESS wasn't hunting for microlensing. It wasn't built for it. But scientists went digging through TESS's archived data anyway, and they found it. TESS had actually been staring at that exact region of space during the event. Not only that, it had recorded the entire brightening in astonishing detail. And hidden inside that data was something even more exciting. A tiny deviation, a brief extra flicker. exactly the kind of fingerprint a planet leaves behind. Against all odds, TESS had captured proof of a world it was never built to see. This newly discovered planet has a name, Gaia 23 BRAB. It's what astronomers call a super-Jupiter, a gas giant even more massive than Jupiter itself. It orbits an orange dwarf star, about 80% the mass of our Sun, at roughly the same distance Jupiter orbits our Sun. The whole system sits nearly 40,000 light-years away, out along a dense, star-crowded stretch of the Milky Way's disk. Most of the famous exoplanets you've heard of sit just a few dozen or a few hundred light-years from Earth. Gaia 23 BRAB is hundreds of times farther than that. Its discovery proves TESS can study parts of our galaxy it was never designed to reach. One accidental observation just expanded what this telescope is capable of. Astronomers, including the University of New Mexico team behind this discovery, are especially excited about one thing. This wasn't a brand new observation. This data had been sitting quietly in TESS's archive the whole time. If one microlensing event was hiding in there, how many others have gone unnoticed? Nearly 8 years of observations might contain signals nobody thought to search for. Entire planets, already recorded, simply waiting to be recognized. This matters even more now because NASA's upcoming Nancy Grace Roman Space Telescope is being built specifically to hunt for thousands of planets using this exact microlensing technique. TESS's accidental success just became a training ground for reading those future discoveries. Science usually moves forward through careful planning, but every so often, it moves because someone got curious. A telescope built to watch nearby stars ended up revealing a world nearly halfway across our galaxy. Not because engineers planned it, but because someone asked one simple question. What if we looked? Somewhere inside the mountains of data we've already collected, there may be hundreds of undiscovered worlds, not waiting to be created, not waiting to be observed, just waiting to be noticed. The next great discovery in astronomy might already be sitting on a hard drive, waiting for someone curious enough to go looking.